Okay, so good day, BS Math. So our today's discussion is mathematical induction or principle of mathematical induction. So it's a proof technique that shows the statement P of n holds for all integers n from some starting point and sum that onward by. We need to verify these two things: a base case wherein P of n sub naught for the initial value for n, then proving that n is equal to k, which is the hypothesis. Then we will go to induction for k plus 1, that it's for all k or arbitrarily k greater than or equal to n sub naught. So let's have an example for that. Example 1. So let's consider the sum of the first integer, first n integers. So that is given by 1 plus 2 plus 3 plus so on hanggang n. And that is equivalent to the most well-known formula by Gauss and n plus 1 divided by 2. And take note, we can relate this one as I, or I is equal to 1 to n. Okay, so solution, we need first to have a base. So the base is for n is equal to 1. Then we have here 1. And then if n is equal to 1, we have 1 is equal to 1, 1 plus 1 over 2, which is 1 times 2 over 2, which is 1. So your left and right is 2. So therefore, it holds the P of 1. Now, let's go it on the induction or the hypothesis of induction or the HOI. Says for n is equal to k, such that k must be greater than or equal to 1. So we have 1 plus 2 plus 3 plus um, hanggang by k, and that is equal to um, n times, oh sorry, it's k na pala. Okay, it's recorded na ba? Yeah, recorded. So we have n. So instead of n is equal na n na, magiging k na yon. So have k times k plus 1 divided by 2. And then this, take note that this is our hypothesis. For the induction, um, we have here POI, proof of induction, or the principle of induction. We have n is equal to k plus 1. So 1 plus 2 plus uh, until kay k, then add tayo ng k plus 1 both side, and that is equal to k, sorry, yeah, k plus 1 over 2 plus k plus 1. So take note, should be the same, likely na magiging um, dapat it would be target that this must be equal to k plus 1 times k plus 2 over 2. Okay, so that is the case. We have k plus 1 over 2 plus k plus 1. Kasi ito yon yung ating hypothesis of induction. So ito na yung ginawa. Let's solve this one. K plus 1, that is k squared plus k plus, or we can just um, okay, so first now take the denominator LCD. So we have over 2, so k times k plus 1 plus 2 times k plus 1, and then that is equal to k squared, wait now, pwede ko na lang palabasin yung k plus 1 para dasig, sorry. Anyway, sige, target na lang natin, sorry. So this should be k plus 1. So palabasin ko to k plus 1, and then this one, yung matitira is k over 2. So that is k over 2 plus 1. Tama. And then that would be equivalent to k plus 1 times, ito magiging 2 over 2 yan. So k plus 2 over 2. And then, um, we will end up dito na lang lagay. This will become k plus 1 times 2. Then, wait, sorry. Multiplication na pala. Times k plus 2 over 2. Which is, we got the same. Ito and this one. So, that's indicate that that is true for all k greater than equal to 1. And thus, um, P of k implies P of k plus 1 for all k greater than or equal to, um, at least we can, yeah, pili na rin, and sub not. Or you can just use 1 kasi 1 yung n natin, which is equal to 1. And done. Okay, number 2. Exercise number 2. Sum of squares. So the sum of squares, wait lang. Okay, sum of squares, given the sum of squares of 1, 2 squared plus 3 squared plus n squared, and that is equivalent to n times n plus 1 times 2n plus 1 divided by 6. So note that this one is summation of I squared, for I is equal to 1 to n. Okay, solution. Base, we need 2, n is equal to 1. So if n is equal to 1 dito, 1 squared is 1, 1 plus 1, 2 times 1 plus 1 divided by 6. Okay, and so ito 1, ito naman magiging 2, ito magiging 3. So 2 times 3, that is 6. So cancel, that is 1. So that's solved our P of 1 is 2. So let's proceed to the hypothesis. For the hypothesis, HOI, hypothesis of induction, we have n is equal to k. So we can just write there um, summation of I is equal to 1 to k for I squared. And that is equivalent to k times k plus 1 times 2k plus 1 divided by 6. Then after that one, then we have POI is part of induction. We have n is equal to k plus 1. And take note, this kind of proof is what we call the weak proof. Meron ba tayong strong induction? So that is now summation of I is equal to 1 I squared, and that is k plus 1. So therefore dito mag-add lang tayo ng k plus 1 quantity squared. 2k plus 1 over 6 plus k plus 1 squared. So ito lang yung gin-add natin kasi nag-k plus 1 na siya. Note of that one. So ang target, goal, or the target na lang, we need to show. Note, we need to show, this one is a scratch work lang that is k plus 1, then k plus 2, then that is 2k plus 3 divide by 6. Diba? So, ito yung kaya-target natin. Let me insert another page. So, na yun. Okay. So, after this one, k over k plus 1 to k, we will solve that one for targeting this one. Yung dapat makuha na. So, given ito, we have k plus 1. Diba? Pwede natin kunin yung another dito na k plus 1 at k plus 1 yung matitira. Okay? So, we will get that k plus 1 there. So, k plus 1 times yung matitira, k times 2k plus 1 divided by 6, and yung natira sa kabila is k plus 1. Then, create natin to, transpose to with the same denominator, that is 6. So 6, then so k plus 1 times 6k plus 1. Then we have here k plus 1. So dito, given na to, k squared, no? This will become 2k squared. Sige, try natin yan. Kasi para meron. So this one is 2k squared plus k plus 6k plus 6 divide by 6. Okay, so may common ka dito makikita. This one, 7k. Note that still we multiply this one sa k plus 1. Then this will become 2k squared plus 7k plus 6 divided by 6k plus 1, and that's it. Now, yung 2k squared, 7k plus 6k, actually pwede natin ito ma-factor out. We can factor out that one to equal dito na lang 2k squared plus 7k plus 6. So plus I can just write na lang 3k plus 4k plus 6k 6, and then pag kunin ko to si k plus 2, pag 2k, yung natitira dyan is 2k, sorry, 2k squared plus 4k plus 3k plus 6. Trabasin ko dito si 2k. So, magiging k na lang dyan. Plus dito 2. And plus dito is yung common is 3. And that is k plus 2. Okay. Ito. So, we can create that as 1 na lang. Ito. And this one. So, we have 2k plus 3 times k plus 2. So, we will have k plus 1 times 2k plus 3 times k plus 2 divided by 6, which is this is our target. Ito, and thus it implies that p of k to p of k plus 1 for all k greater than 2 1. Okay, so let's proceed on example 3. We have for any integer n greater than or equal to 1, we have 7 raised to n minus 1 is divisible by 6. Okay, so solution, base let n is equal to 1. So if 7 raised to 1 minus 1, that is 7 minus 1 is 6. And then um, that is divisible by 6. Sorry. So P of 1 holds. Um, so let's go it on HOI. N is equal to K. For N is equal to K, we have 7 raised to K minus 1 is equal to 6n. So take note, I add m, that is for some integer n. Integer n. So let's go to POI. So for n is equal to k plus 1, we have 7k plus 1 minus 1 is equal to, should be, take note that our target there is, we need to have this one. So this one must be equal to 7k times 7 minus 1. And can I write dito, um, okay, so then after that one, we have 7 raised to k. Sorry, pwede ko rin pag-on 7. 7 and then multiply by 7k. Um, then, instead of here, mag-add ako dito negative 7 plus 7. makukuha. So, ang mangyayari doon, negative 1, 7, I can write dito sa 7. Ma'am. Ano ma'am? This one. Ano yan ginagawa ko? Okay. So, we will rewrite this one, 7K to, wait, mamaya ko na lang palabasin to sa 7. Hmm, ito ang nangyayari dyan. So, si 7 at, ito. So, 7K plus, um, plus 7K. Tignan ko. Tignan ko lang. Wait. Sorry. Baliktad. Dapat mabiling. C, okay. Should be negative 7. Kasi need natin 7K minus 1. Tapos, yung natira dyan is minus 1 minus 7. Oh, sorry, plus 7. So, lalabas dyan is, ito, pwede ko siyang rewrite. Lalabas is 7. 7K minus 1. Then, yung isa dito is magiging plus 6. Okay? And note that yung 7K natin, by hypothesis of induction, ito, that is equal to 6m. So, we have 7 times 6m plus 6. And that is equivalent to, um, take note that we can write yung baliktarin natin, di ba? Kasi inaabol natin is yung 6, which is divisible by 6 yan. Okay, o sige na lang, plus 6, and then that is 6, tapos natira is 7m plus 1. And since yung m is an element of integer, so therefore, this one is also an element of integer. Thus, that is, hindi natin maglagay ng cube 1. Thus, that is true for all n greater than 1, which is divisible yan. Okay? So, next is, what if given? Next example, for every integer n greater than 0, we have 2 raised to n greater than or equal to n plus 1. So, solution, we have base n is equal to 1. We have here 2 raised to 1 greater than or equal to 1 plus 1, which is implies 2 greater than or equal to 2, and that is 2 for p of 1. So HOI, we have n is equal to k, 2 raised to k greater than or equal to k plus 1. And for POI, n is equal to k plus 1. We have 2k plus 1 greater than or equal to k plus 2. Okay? And then, for this, you can just multiply na lang ito. No? Okay, ma'am. While recording. Okay, so then next, wait na meron dito, mag-record. After this one, 2k plus 1, can we write this as 2k times 2 greater than or equal to k plus 2. And note that 2k is, yeah, is equal to k plus 1. So we have this one, 2k plus k2, 2k plus 2 greater than or equal to k plus 2. Is this true? That is yes, because 2k plus 2, pag i-deduct mo tong k minus 2, that is equal to, ilan pa? Is equal to k, which is, as we know, k is greater than or equal to 0 since n is greater than or equal to 0 for any n. And thus, ito, the conclusion. So let's have here a next example. example na ba to? 4, 5. I forgot na. Okay, anyway. So for any n greater than or equal to 4, we have n factorial raised to 2 raised to 10. It's always greater than 2 raised to 10. So solution base for n is equal to 1, we have n factorial is 1 factorial plus 4 plus 4. So that is 4 factorial, and 4 factorial is that is equal to 24. Is this greater than ba 2? Ito, 2 raised to 4, which is 16, and that is true. Okay, so for hypothesis of induction, we have n is equal to k. So we have k a factorial greater than 2 raised to k. Then we have induction POI, n is equal to k plus 1. K plus 1 factorial is greater than 2k plus 1. Okay, so then we have k plus 1. Pag-on ka na lang. Tapos k factorial is greater than 2k times 2. And note that yung k factorial and 2k is this one. And that is always 2. Why? Because that is always true for k plus 1 is greater than 2. Kasi k factorial can be equal to 2 raised to k. So I can write here k plus 1 times 2 raised to k. We cannot create a less than or equal there. 2 raised to k times 2 kasi 2 lang ito. And 2. It's always k plus 1 mas itaas since k is greater than or equal to 2. So if k is greater than or equal to 4, so always left here. So we have k plus 1 is greater than cosecant answer. So thus um, p of k implies to p of k plus 1 for k greater than or equal to true is true. Particularly that is for all and greater than or less. Okay, the next is telescopic. So we have a telescopic sum. The last example, summation of 1 over I times I plus 1 is equal to n over n plus 1, where your I is equal to 1 to n. So solution, so example, base n is equal to 1. So we have if n is equal to 1, ito 1, actually the same yung mangyayari na. That is 1 and 1, 1 plus 1. And ito is 1 tapos 1 plus 1. Ito 1 half and ito is 1, 1 half pa rin. And that is 2. P of 1 is 2. Okay. So for n is equal to k, we have summation of I is equal to 1 for 3, and then 1 then I plus 1 and k over k plus 1. Okay, here by inductive HOI, AOI, n is equal to k plus 1. We have here I is equal to 1, k plus 1, I plus 1 equal to k plus 1 over k plus 2. Okay, okay, sorry. So this is our target actually. So when we reclaim this one by k, iba, ito. So kasi may k plus 1 pa to, di ba? So we can have k by hypothesis, k plus 1 plus ito, yung sa ilalim yan. That is 1, yeah, it's 1. Tapos, k plus 1 and k plus 1 plus 1, so that is 2. And then we need to show that, okay, we need to show that is k plus 1 over k plus 2. Oops. Okay, this is not included. Okay, dito, um, okay then, so the common denominator, k plus 1, k plus 2, and first one yan. Dito magiging k times k plus 2. And that is k squared plus 2k plus 1 over k plus 1 times k plus 2. But um, here, this one, we can write k squared plus 2k plus 1 exactly as k plus 1 quantity squared. And that is k plus 1 squared over k plus 1 times k plus 2. And ang second cell, yung natitira is k plus 1 over k plus 2. And that's the show that p of k implies p of k plus 1. Thus, that is all true. Plus, um, the identity, yung identity sa taas kanina, holds for all n greater than or equal sa ba tayo start 1.